Hello again everybody and welcome back. In the last video we took a look at character recognition using KNN and machine learning in C++ and Python with OpenCV, and in this video we're going to replicate the same project but within the .NET environment using Emgu CV as an OpenCV wrapper. So let's go ahead and get started. So GitHub, microcontrollers and more. And there we go, it'll pop right up for us. And we're going to go to here and then repositories, and so this is what we did last time: OpenCV, KNN, character recognition, machine learning, and this time we're going to do the same thing but in Visual Basic or C#. So I should probably first mention some prerequisites. The first one is the, let's see here, is the OpenCV 2.4.11 installation guide, specifically the Emgu installation of that, which is right here, part 3, OpenCV 2.4.11 Windows 7 installation guide, part 3. That's actually using Emgu CV 2.4.10. And here is the repository for that. And then also definitely, if you're not familiar with KNN or machine learning or character recognition, I would recommend checking out this previous repository here, which we also have a video for that, which is this video right here. Of course, by the time I'm done recording this video, there'll be one more on the end, and that's this project here. So let's dive into it. So we have some images to download here. .png. There's 4 images here. So the first one is test numbers, and training numbers, I should say, are the first 2 we'll download. And those, if you're familiar with the previous video, you'll know what those are. These are going to be the numbers we'll read at the end of the second program, and then training numbers is 0 through 9. These are the digits we'll use to train in the first program. And let's see, form design, these are the 2 forms we're going to be making today: save picture as, save everything to the desktop, and classification and training images data structures. This has to do with some data structures. We'll get to this in code later, but essentially because of some differences in Emgu, we have to manipulate some data structures manually a little bit, but it's not very difficult. We'll get to that later. So what are that was these 4 files here. What are the remaining files we have? The README basically just goes over the prerequisites, which I already mentioned, and then refers to the video that you're watching right now, so you don't really need to look at that. And then the remaining 4 files here are generate data, C# or Visual Basic, that's the first program, and then train and test, C# or Visual Basic, that's the second program. So let's dive right into the first one, generate data. And then as we're making the program here, all I'll be doing is going to raw and then copying and pasting right out of here. So let's take a look at these images here. Test numbers, let's see, training numbers, test numbers, form design, and classifications. And then we'll also be working from the cheat sheet. Part 3, that's the same as the installation guide. So let's go ahead and fire up Visual Studio and get the program going. So we'll go ahead and call it generate data. So X out of that, file, new project, Visual Basic, Windows Forms application, and we'll call it generate data 1. There we go, our preferred location, uncheck those and choose OK. And then save, and again I'm just following the steps on the installation and configuration cheat sheet at this point. So we're going to go ahead and rename the form. Better to do it now when there's fewer references. So we'll call that FRM main. And yes, we want to update all references. Save it again. Okay, now we're going to go to project, add reference. Where's add reference? There we go. Browse, and then choose all of those. Visual Studio 2013, okay, that's good, and choose OK. And next we're going to go to project and add existing item, and then we're going to go to C, Emgu, Windows Universal CUDA, bin, and x86, and then we're going to go to all files and choose all of those, and then add, and then save it. And then we're going to choose these and then go to Solution Explorer and change properties rather, and then change copy to output directory to copy always. And now we're ready to add some components to our form. So we're just going to add these components here. So we're going to add button open training image. So let's close out of this here, minimize all these, menu data, we don't need to see all that, components dialogues, okay, where are we, common controls, and then dialogues we'll need later, so button, put that on there, and let's go ahead and name them as we're adding them, so whoops, not toolbox, properties, and there we go, and there's button open training image, and then we'll add the label and name that as well. So label, and then label chosen file, and then our text box I believe is next. Yes it is, text box, drop that right there, and we'll name that. And then the open file dialog box, it's under dialogues here, open file dialog, and we're going to name that as well. Okay, so actually we're going to need one more from the toolbox here. Let's close this, and we'll go to containers and then table layout panel and put that there. And let's close out of that for a moment, and we can make the form bigger and make this bigger, and then we're going to put our button in the top left and the label in the top right, and then the text box in the lower left. And then we're going to move this back up to here, resize the form a little bit, and bring these back up, and now we're going to change some properties. We can close out a toolbox, so let's grab the button and the label here and set the font. We'll go ahead and set that to 12. Make it nice and big. And for the button, let's go ahead and set the text now. So all we're going to do is we're just going to make our form look like this here. So let's put this on the other screen to give myself something to work from. So the button should say open training image. So let's see, text open training, training image. And then the label, we can leave the text blank. Actually, let's highlight both the button and the label, and then go to anchor, and then anchor to left and right rather than top and left. There we go. Okay, let's choose the text box and then column span, and we'll make that 2. And then we're going to choose the multi-line property. So let's see, this is for the text box here, multi-line, and set that to true. And now we can go ahead and choose doc for the text box, and that will fill the bottom too. And then let's choose doc for the table layout panel as well. That'll fill the form. Okay, so for the button now we have the correct text on there. Actually, let's correct the label text here. So text align, let's make that just left, not top left. And we can make the text blank. So that's good. So now if we choose, let's see, we want to choose just the button for one final property for the button here. If we go to auto size, set that to true, and then auto size mode grow and shrink. There we go. Okay, now we're ready to edit the rows and columns for the table layout panel. So let's see, for the columns we would like, well, let's do the rows first. So we would like this top row essentially to shrink down only to the minimum height required for the button. So row 1 we'll choose auto size, and then essentially the same thing but for the first column. So for columns, column 1, auto size. And there we go. Let's go ahead and save that and run it. And just make sure that everything resizes nicely on our form. Yep, there we go. Text box resizes with the form. We're all set there. So the next thing is to make sure that we name the button, which I'm pretty sure we already did. Yes, button open training image. Now we can double click on that, and that will start to write the open training image click event for us here. Let's just resize the text a little bit and go back to our form here. Okay, and so at this point we're ready to write code, or copy and paste code in as the case may be. So again, this is simply this raw view of the code earlier. I'm just going to shoot down here and copy and paste in everything that isn't there already. So starting from the top, we can copy and paste in all of that. And then we have some module level variables that will go right after here. There we go. And then we have a substantial amount of text in that click event. That's actually where most of the code is. And that's going to go, whoops, got to redo spacing here just a smidge. Paste that in there. And then do that. And let's go back up to the top of that function and grab the comment line as well. And that's in there. Okay, that's good. And then the only thing left is this one very small function at the bottom. And we'll go over the code a little bit more, but let's get the program working successfully first. So contour is valid is the last remaining thing, I believe. Yes, there we go. Okay, and if I didn't forget anything, that should be all set to fire up. So if we go to run and then open training image, so we'll go to our desktop and then we'll choose our training image. Where is that here? Training numbers.png, and I'll just call the numbers out as I type them in here. 754986321 and 0. Training complete and file writing done. That font's kind of small there. I forgot to set that property. And of course what I meant to do was choose the text box here and then make the font 12. There we go, that's a little better. Go ahead and train again, open training image, training numbers, 754986321 and 0. There we go. Training complete, file writing done. So let's take a quick look at the code, and I'll kind of go through this to a degree, line by line, not in too much detail. I try to write the code here to be relatively self-documenting as far as picking clear variable names and thorough commenting and so on, but we'll just sort of take a quick pass through it. So to start with, we have some module level variables here. These are pretty straightforward, again very similar to the previous program. Contour area, that's the only criteria we're using for a contour, is that it's an area of at least 100. Then we have our resized image width and height, and then we keep track of the number of training samples. And here's the click event, essentially the only really substantial function in the program. So we have our dialog box, we get the file name, and here's where we declare our main image training numbers, and then this is the line where we open it. Then we have some error checking here, and then we update the label chosen file.txt, that's this label here, with the file that was chosen. Now we're going to next declare some images here that we're going to use throughout the rest of the program. So grayscale, blurred, thresh copy, and contours. And then this is contours image, and then we also have our actual contours variable here. So the next thing we're going to do is declare list invalid characters. This is our valid characters, so in this program we're only looking at digits 0 through 9. So here they are. And you can see it would be very straightforward to add uppercase or lowercase letters to this list, or both if you like, but we'll keep it as simple as possible today with the digits 0 through 9. Then we get the grayscale image here, and then we Gaussian blur that here, and then call adaptive threshold to get down to a black and white image here. That's thresh. And then just for reference, we show image thresh here. And then we clone that before calling find contours. So we call find contours on the threshold copy image. And recall from the previous program, we're only going to get the external contours. And then number of training samples, we're going to knit that to 0. And then we have this next block of code, which is this substantial size while loop. Actually, first we have to count the contours before we get to the larger while loop down here. So counting the contours, that's simply a matter of incrementing our number of training samples and then stepping through the contours with this statement. Once we've done that to count the contours, so this will now contain how many contours there are, we reassign to contours from the find contours method to get back to the beginning of it, because of course this statement steps us through to the end. Then we instantiate the contours image and draw our contours on the contours image, and then show the contours image. That's just for user reference, so you can see the contours image as you're following the program through. And then we declare our main two data structures here, classifications, so those were the numbers that we were keying in as far as each image was that number. And then matrix training image, that's the actual training image. And then in training data row to add, that's keeping track of what number sample we're on as we step through our 10 samples. And then finally we're to our big while loop here, and this is what that slide that we took a look at earlier was for. Let's refer to that quickly. Classifications, here we go. Okay, so our first data structure, matrix classifications, that just keeps track of the numbers. That's pretty straightforward. It's 10 rows because in our program today there's 10 samples, and each column is only one across, of course, because it's just a number. So this will be 10 numbers straight down. However, matrix training images is substantially more involved. I should probably mention matrix classifications and training images. We have to use the matrix variables here because the k-nearest train function, which we're going to get to in the second program, only accepts the matrix data type. So you can't make this, for example, a list of integers, say, and then make matrix training images a list of Emgu images. That might, at first you would think that would be the easier way to do it, but the KNN train function will not accept those. It only accepts the matrix type. So this conversion is necessary for the images. What we're going to do with the images is after we've cropped out each individual character, we're going to resize it to 20 by 30. Then we're going to call CV invoke.cv convert to convert that to a matrix temp of 20 by 30. Then we're going to have a nested for loop that's going to reshape this 20 by 30 data structure into 1 row by 600. So that is to say, each sample, one row corresponds to each sample. So then we're going to have another for loop. This is just the one current image. So we're going to have another for loop to write this into the respective 10 rows of matrix training images. So our 10 rows corresponds to our 10 samples, and then the 600 across is the actual image data. So let's take a quick look at that in code. And here we are. So while contours is nothing, so we're going to loop through the contours, and we declare this variable here for the current contour, and then if it's valid, and that simply calls this function down here, which checks if the contour area is at least 100. Obviously, in a production grade program, you would need substantially more stringent considerations for if something is a contour or not. Then we declare a rectangle, and we get the bounding rectangle of the current contour, and then we're going to go ahead and draw that rectangle in red. So that was the red rectangles you saw as we were going through the program entering the numbers. Then we're going to get the ROI image specifically of that character. Then we're going to resize that. That's that 20 by 30 image ROI resized. And then just for user reference, we show image ROI resized, and the training numbers image as well. Then we get the current key pressed. You recall we were keying in the numbers earlier. So if the escape key is pressed, that's ASCII 27, then we return from the function. Supposing that the escape key was not pressed, if the current character that was entered in character is contained in the list of valid characters, and that was this list up here that was 0 through 9. So supposing the number that was entered was the number, one of the numbers 0 through 9, then this statement here, we're going to add the digit to matrix classifications. So this line here is, whoops, I should not have closed that image from earlier. Okay, there we go. Just a moment. Okay, so this line here is writing the number into matrix classifications, this data structure here. And now this portion down here is essentially the rest of this else if, this portion here. So what we're going to do is we're going to declare matrix temp and matrix temp reshaped. Then we convert image ROI resized into matrix temp. So this will now be a 20 by 30 image, or not a 20 by 30 image, I should say a 20 by 30 matrix. And then this is the loop here that rewrites from being in a 20 by 30 matrix to being in a 1 by 600 matrix. And then this is a loop here that takes the one sample, so one row by 600 columns, and writes it into the matrix training images structure, which contains all, in this case, 10 samples, because we had 10 samples in our data set. Then we increment what row that we're on. So recall in training data row to add, we rather initialize that to 0 up here, and then we increment that by 1 time. So the first time through this else if training data row to add will be 0, then it'll be 1, 2, etc. as we step through our images as we're adding them to matrix training images. Then we show on the text box that training was successfully complete, and then we save our data to file, and we'll take a quick look at that momentarily. So this is a pretty standard .NET code for serializing things out to a file. .NET's very friendly as far as serializing data out to XML files. It makes it pretty easy for you. This is pretty straightforward, and that completes the program. So let's take a quick look at those. So if we go to C, Visual Studio 2013 Progs, let's see, Visual Basic, generate data, and then bin and debug, and you want to go to the file, to the directory rather, with the executable file in it. That's where these files are going to be written to. So here we have classifications.xml and then images.xml. Let's take a quick look at each of them. So if we open classifications.xml, looking at this, you couldn't really tell that this is the digits that we entered, the way .NET serializes it out, but if you look at the number of columns, that's 1, and the number of rows, that's 10. So again, that matches this, just as it should. And then if we go to, let's see, let's close out of this, and then if we go to images down here, again, looking at this, you couldn't really tell that that's image data, but if we look at the number of channels, that's 1, which it's a black and white image, so it should have 1 channel, 600 columns and 10 rows. So sure enough, that's this data structure here. So that worked successfully and we're all set. And we have images and classifications ready to use in our second program. So now we'll go ahead and do that. So we can close out of Visual Studio and let's minimize that for the moment. So back to the GitHub page here, and then we'll go back and back again. So now we're going to go to train and test.visualbasic. Yes, that's good. And then raw. And now we're going to set the project up again. So let's see, we can close out of that, and now we can go to train and test.vb. So file, new project, and we'll name that train and test 1 Visual Basic Windows Forms application, and choose our preferred directory here. So that'll be Visual Basic. Okay, so Windows Forms application, train and test 1, C, Visual Studio 2013 Progs, Visual Basic. Uncheck those, that's good. And that should have created our project for us. Yes, it did, that's good. Okay, go ahead and save that. And resize the form a little bit. And now working down through the installation cheat sheet, go ahead and rename the form here. FRM main, yes, we're sure we'd like to rename, save. And now we're going to go to project and then add reference and then browse and browse and choose those. Yes, that's good. And then OK. And now we're going to go to project, add existing item. And then we're going to go to C and Emgu and Windows Universal CUDA 2410, bin, x86, and all files, and choose those, and then add, and then choose those, and open these up here, go to copy always, and save, and now we're ready to add to our form here. So now we're going to create this form here, train and test. So what do we have here? Some, let's see, close this, minimize this, we don't need all this open. Printing dialogues, okay, common controls, and then dialogues. So we need a button, and a label, where's label, there we go, and a text box, go ahead and add that, and then open file dialog. Okay, so now going back to the raw code here in train and test, we can just copy the names out at the top here. So button, let's see, toolbox properties rather, move up to the top, button open test image, and label chosen file will be next. Go ahead and name that, and then the text box as well should be txt info, and then a file dialog box. Whoops, there we go, copying and pasting from the other screen. Okay, and let's see, next we're going to go to containers and table layout panel, and now we can bring properties back up, close out the toolbox. That was the last thing we have to add. So let's go ahead and resize this, and then we're going to put the button there, the label there, and the text box there. And now we're ready to set our properties. So let's see here, choose the table layout panel and then choose doc, fill, and then for the text box we can choose, let's see here, column span 2, and then doc fill. That should fill all the bottom now. Okay, gotta set multi-line though. Multi-line is true. Okay, that's good. Then for the button and the label, gotta make the fonts a little bigger here. So let's choose the text box, font 12, and we're gonna be showing numbers in this. So let's do a fixed width font, Courier News, always good. Then for the button and the label, let's make the font 12, and then we're gonna choose the anchor property next. And we're gonna anchor to the left and right. And now we're going to choose the button, and for auto size we're going to set that to true, and then auto size mode, grow and shrink. And I think we're all set to do edit rows and columns on the table layout panel now. Okay, so columns, column 1, we'd like to make that auto size. That's good. Okay, only thing is I forgot to set the text on these here, so label text align, let's make that left only, and we don't need any text in there by default. And then for the button, the text should be, let's see here, and again I'm just working straight off of this here form design. So for the button, the text should be open test image. Okay, there we go. And now we can go back to here, edit rows and columns, and for the rows we'd also like row 1 to be auto sized to the minimum, and choose OK and save, and let's run that and make sure our form works okay. And there we go. Okay, that's good. Now if we go to view code, and whoops, forgot to make the button click event. So let's make sure that we have the button named correctly, btn open test image. Yes, we do. Go ahead and double click on that. That'll start to write that for us. Make that a little smaller. Close out of that, and now it's simply a matter of copying and pasting the code that isn't there yet from the raw file. So again, copying and pasting here, I'm simply copying and pasting out of, if you go back to here, train and test.vb, and then raw. And then I'm just going to copy and paste, shoot on down everything that isn't there already. And then we'll go, well, first we'll run the program, then we'll go through it line by line. Okay, so paste in the top there. And whoops, then we have some module level variables that are next. So let's go ahead and grab those, and those go right there. And then let's grab this comment line here. It goes right there. And then get that in place. And we'll fill that in just a moment. Okay, now we can grab the longest part of the program here, that's the button click event. So we're going to paste that right there. And now at the end we're going to put our check if valid function. And I believe that's it. Yes, it is. Okay, so if I haven't forgotten anything so far, the only thing left should be of course this program has to look at the classifications and images XML files that we made in the previous program, so we have to move those over as well. So if we go to generate data and then bin and then debug, that gets us back to classifications and images. Highlight both of those and then copy that, and then we want to go to train and test, bin, and debug, and then we want to paste those in there. Okay, so now this program will be able to find them, so we should be able to go ahead and run it if I didn't forget anything, which I certainly hope I didn't. There we go. Okay, so open test image, and on the desktop we have our test image. Again, you can use any sequence of numbers you like. I just chose pi randomly, and there we go. We got a successful read. I'm not sure if everybody's necessarily watching this in 1080p or not, but the text here says 3141592655359, and that's the same as the numbers in our test image, except of course for the decimal point, which we weren't trying to read. So success. So let's quickly go over the code here. This is pretty similar to the previous program, so I don't think it's really necessary to go over it in too much detail. This part up here is the same, and our module level variables are essentially the same. And then we get into the click event. So we have matrix classifications and matrix training images. Those were the two data structures we took a look at earlier. Invalid characters is the same. That's just number 0 through 9. And then we have our XML serializer and stream reader to work with the files. I tried to comment this up here. This is a little bit strange at, let's take a look at this again here. If we go to debug and then classifications or images, either one. So images is the larger of the two files, but in either case we have 10 rows, and then in the case of images we have 600 columns. So supposing, in this simple example, we have 10 samples corresponding to our 10 rows, but suppose that you didn't know the rows ahead of time. So what we effectively have to do is we have to open this file the first time, not actually read any of the data, but we're just going to read the 10 rows to get that number. Then we're going to open the file a second time and actually read the image data. That's what this next block of code is all about. So that it seems a little obscure at first. I tried to mention that in the comments here and explain that as well as I could. But anyhow, matrix classifications and training images. So we have our XML serializer and stream reader, and then we go ahead and open the file classifications for the first time. And you'll note the first time that we declare classifications, we're only declaring that as a one-by-one matrix, and the same thing with training images. Obviously those will not stay that size. That was just to pick any numbers to put in there until we knew how many samples there's going to be later on. Okay, so we're going to assign to matrix classifications here. That's going to open the matrix classifications file. Then we're going to go ahead and close that. And then we're going to assign matrix classifications.rows to our number of training samples. So at this point here, we now have our number of training samples known. So now we have to reallocate matrix classifications and matrix training images with the known number of training samples. Now we can open classifications for the second time and actually read the 10 samples, which is what we're doing here, and then we close that and then reassign XML serializer to training images, and then we open images.xml and then we go ahead and read that and then close images.xml. And now we're ready to train. So here finally, after all that, we can instantiate our KNN object, and then this here is our call to knn.train. And there's passing in matrix training images and matrix classifications. And now we're ready to go ahead and test on our test image. So again, this code is pretty much the same as the previous program. I won't go into it in too much detail. You're just opening the file and reading into image testing numbers the contents of the image where we're going to read the numbers from. And then we open, we rather update the label on the form with the file location and name. Then we declare our variables here: grayscale, blurred, thresh, and thresh copy. And again, these steps are very similar to the previous program. We also have our contours variable. And then we have, so next we convert image testing numbers into grayscale. Then we blur it. Then we get the threshold. That'll be a black and white image now. And then we clone that before calling find contours. Then we call find contours, once again taking only the external contours. And then we have to read the contours variable into a list of contours and a list of valid contours, because it's easier to work with for sorting and so on later. We'll see that in the subsequent code down here. So the first thing we're going to do is step through contours, and we're going to populate our list of contours. So this line steps through our contours variable, and then we increment that just before we continue the while loop. And we're going to get the current contour with this statement here, and then we're going to add that to our list of contours with this statement here. So at the end of this loop here, this will be populated, and now we're going to get the valid contours only, or in other words, remove the invalid contours. So for each contour in list of contours, if the contour is valid, then we're going to add it to list of valid contours. So that simply calls this contours as valid function down here, which again only checks that the area is at least 100. In a production grade program, you would need substantially more checks than that. But at this point, we have list of valid contours populated, and this line here will sort the list of valid contours from left to right based on the X position of the bounding rectangle of each character. And that's necessary because, of course, as you saw when we entered the data in the first program, the find contours function doesn't find the numbers from left to right necessarily. In fact, it usually finds it in a completely different order than that. But we have to write the number out to the screen in the same order as the image is read from left to right, otherwise it'll look like we didn't read the numbers correctly. So this sort step here is essential, and that's really the driving factor behind getting the contours into a list format rather than leaving them as this contours type up here. And then we're going to declare our final string, initialize that to blank. And now we simply step through each contour. So for each contour as contour point in list of valid contours. So we're stepping through list of valid contours here, not the actual contours type variable here. We're no longer using that one. We're now using our list of valid contours. And again, this will look relatively similar to the previous program. So we declare our rectangle. That's going to be the bounding rect of the current character, and then we're going to draw a green box around that, and then we have our image ROI and image ROI resized. So for matrix temp reshaped here, I should probably mention kind of what we're trying to achieve with this next block of code here. Eventually, into the KNN object's find nearest function, we have to pass in matrix temp reshaped, which I should probably bring this slide up here. So essentially we have to replicate the first 3 steps of this process. We don't need this 4th step because we don't need all 10 training images, but we need to get to this format to pass it into the KNN object. So that's what we are doing here. So convert, let's see, so image ROI resize, that's our 20 by 30 Emgu CV image, and then convert is going to get us to our 20 by 30 matrix, and then this nested for loop will get us to our 1 by 600 matrix by the end of here. At this point that'll be matrix temp reshaped, and then we're going to declare and assign to the current character the result of the find nearest function. We're going to pass in matrix temp reshaped. This here is the value of k. Of course we can't make that higher than 1 because we only had one instance of each sample, and you can usually set these to nothing. And then at that point we're almost to the end here. It's simply a matter of taking the current character, converting that to an integer, and then this function here will give us the ASCII character of that, and then we append that to the final string which we showed on the form. And then here we show the final string on the form. That's this here, and then we show the image as well for user reference. And that completes the program. And so hopefully anybody out there that's trying to implement this in Emgu CV will find this as a helpful reference. The next video that I'm moving on, I'm planning on doing a license plate detection video. I was looking at some of the videos on YouTube, and there's a lot of demonstration videos, but nobody really has a video similar to this one where they step through how to perform license plate and show the code fully. So I think I'm going to do that next. If anybody has anything else in mind or just any kind of reflections or comments, please share them in the comment section below, and I'll see everybody in the next video.